Hey, hi everyone. Welcome to Nexxgen AI Academy. And from today onwards, we'll be starting a new playlist on generative AI. And the people who are already aware about DALL and ML concepts can follow this series. And the people who are not even aware about any concept regarding data science, ML, and AI also can follow this series. In this series, we'll be learning about what is generative AI, what are the limitations of generative AI, and how generative AI application builds. We'll also focus on generative AI frameworks like LangChain. We will go deep dive into AI agentic systems and many more, right? So the today's discussion will be focused on introduction of generative AI, right? So mm, first, Annie can ask about what is generative AI, right? So generative AI refers to the models that can create new content, right? The models we already studied in ML and classical DL approaches doesn't generate any content. They either do classification, either they are modeled to do predictions, regression based predictions, right? Or either they can optimize the current systems, right? Like ranking systems or recommendation engines, right? But the generative AI refers to the field of AI where the model are trained on large data sets and the output would be in the form of text, would be in the form of videos, audios, code, etc., right? And unlike traditional AI, it focuses on generating rather than prediction, right? So if I talk about how should a generative AI application should look like, so let's say this is a model, right? This is trained on some large data sets, right, and this is trained. Now when a user comes, it gives a query to this model, right? And the output is nothing but content, right? You might have heard about ChatGPT, right? So how ChatGPT works, right? So when a user queries something on ChatGPT, the model understand the text, right? Create tokens, tokens out of it, right? Tokens are nothing but uh, just separating out the words in multiple tokens, right? And then the model furtherly changes the tokens to embeddings, right? If you're not aware about embedding, let me discuss about what our embeddings actually is. So any word, right, can be represented in a mathematical form, right? Mathematical form, or you can say vector, right? So this vector, which is representing any token or any word, so let's say this is a token, right? Let's say my query is what is the color of apple, right? So this is my query. So ChatGPT will give you an answer of, let's say, red or green or whatever. It depends on the context, right? But this what is first token, right? And first the model will convert this what to an embedding, which is a vector, right? So embedding is nothing but a vector in a multi-dimensional space, right? So first, when the model got the embeddings, now the pre-trained transformers will get these embeddings and give you the output, right? So that's how a generative AI application works, right? So unlike traditional, if I talk about traditional AI, right? That's a traditional AI. Uh, let's say you are working on a use case. So your task is to classify the gender of the user, right? Basis basis some user led feature, maybe age, product history, or whatever. If it's a e-commerce led use case, then you can get product, the converted product history, You can take age, you can take demography, etc. A lot of features, right? And your work is to classify whether the user is male or female or unidentified, let's say others, right? So it's a classification related modeling, right? Or maybe you might have worked on some regression related problem statements, right? Let's say I want to predict what would be the stock price, right? So there might be ups and downs in a stock performance, right? But basis using some features, I can predict what should be the optimum value of the stock price, right, at that point in time. So these are sort of regression related use cases. But generative AI is completely different, right? Generative AI is a form of AI, or you can say subset of AI, where you are creating content, right? Let's say, generating content, right? Generating content, right? Content can be in the form of audio, can be in the form of text, can be in the form of video, can be in the form of code, right? Anything. So I think it's now clear that how generative AI is different from classical ML and DL approaches, right? And also ML and DL approaches can be used for optimizations like recommendation systems, right? Anything which you want to optimize, whether you want to optimize a product ranking on an e-commerce platform, whether you want to optimize the links, the ranking of the links on a browser, right? Or you can optimize uh, the stock performance basis regression related use cases, right? All these are use cases of classical ML and DL approaches. But Gen AI is a different subset of AI where it's more focused on generating content, right? So I think it's clear now. So let's focus on the next sections, right? So people uh, might be able to excited about understanding large language models, right? So let's talk about large language models. Sorry, let me just erase it. Large language models, right? Models. Yeah. So any model, right? So you might have went through a research paper called Attention is All You Need, right? Is all you need. This was published by Jeffrey Hinton, who was godfather of AI, right? We all know that, right? So after this research paper, there was a boom came in the field of deep learning, because most of the companies were started using a transformer based architecture, right? Based architecture, right? And why transformer based architecture were important? So these architecture has previous context as well, right? So let's say a query is, this is a cat, right? Cat. So fundamentally, most of the models could understood this, but when they come to is, they forget about this information, right? This. But in transformer, when the model is able to understand the embeddings of this, and when the model understand the next token, the model has already get the context of this as well, right? So it's not forgetting anything, right? Which most of the architecture were not able to do it, but transformer may, we know that we had encoder, decoder level architecture, right? Base architecture. We can get only encoder, only decoder, cross encoder level architecture as well. But predominantly, uh, our main aim here to understand that it has the context of the previous tokens as well, right? And that's why transformer being highly used in the system, in the industry right now, right? So yeah, so if you have heard about GPT, right? Generative pre-trained transformer, right? These are also using the transformer based architectures, right? So solely, if you can say, any complex architecture, DL based or neural network based architecture, which are trained on large text data, right, are known as large language models, right? I hope it's clear now that what are large language models are the neural network or the transformer based architecture models, which are trained on the large text data, right? We have few uh, best in the class large language models in the industry right now, like GPT-4, Claude, Gemini, Llama, right? If I talk about GPT-4, it's built by OpenAI, right? And predominantly very useful while reasoning or doing any logical pre-processing, right? Claude is uh, built by Anthropic, and it's very useful for summarizing information, right? Gemini is multimodal large language model where you can do whole lot of things like text generation, image generation, audio generation, etc., right? Llama, again, it's built by Meta, and it's an open source large language model which can be integrated in any Gen AI application and used for multiple generative use cases like content, um, customer support, right? Image generation, etc., right? So I hope it's clear now what are large language models. It's nothing but uh, transformers or neural network based architecture which are trained on very heavy data sets. And very heavy data sets, I mean trillions, billions of records, right? Because the query can be anything, right? On ChatGPT you can query anything, right? So the model has to have context of it beforehand, right? And these model needs to train every single time while anything new came up, right? So it's very important that large language models has to train, right? Large language model has a very uh, vast data size training, and on top of it they do all the information retrieval task to understand the accuracy and performance of these models, right? So I hope this is clear that what are large language models, right? So next will be understanding about the difference between foundational models and large language models, right? So few students or many of you might have doubt about that. If large language models are also neural network based architecture and foundational models are also neural network based architecture, then what is the difference between large language models and foundational models, right? So the basic difference is foundational models are built for multi-purpose, while large language models are built for specific purpose, right? Let's take an example of Gemini and GPT-4, right? Here Gemini, you can do text generation, you can do image generation, you can do audio generation, right? Multiple use cases. But in GPT-4, you cannot do all of this. You just can query and get the text generation, right? So Gemini is a multi-model foundational model, right? It's a foundational model. You can say this foundational model as multi-model large language models, but GPT-4 is a specific task large language models, right? So I think it's clear now that what is foundational model and what is large language model. So if I create a GPT-4o and GPT-4 diagram, right? So GPT-4 can only perform text generation task, but GPT-4o is a multi-model architecture, right? So it can also generate audio, image, uh, video, etc. Right? So this is your LLM and this is your foundational model, right? So LLM is always a subset of a foundational model, right? And these foundational model again fine tune for a specific task, and then you can create an LLM, right? So first you create multi-purpose foundational models and then break those purposes and use these large language models using fine tuning the parameters, right? So that's how uh, we classifies foundational models and large language models, right? So large language models are not different from foundational models, but foundational models are very heavy and also perform these are multitasking models basically, but large language models basically focus on specific task like GitHub Copilot, right? It's generate the code. It's not generating audio, not video, right? But while few models like Gemini or GPT-4o can do multiple tasks, right? So it's these are foundational models on top of it, right? So I hope it's clear now, and this is for it today. And in next video we'll be talking about how generative AI or generative AI led application works. We'll also be discussing about the limitation of Gen AI and how it was very important to understand that the Gen AI is a revolutionary idea, and how the computation was possible because we didn't had GPUs and CPU computation power before, right? So all these will be discussed in the next video. Thanks. Have a good day.